Inorganic catalysts work efficiently at high temperatures and high pressures, while the enzymes get denatured at high temperatures, say above 40 degrees Celsius, right? However, enzymes are accelerated for organisms who normally live under extremely high temperatures, hot winds, and thermal springs. They are stable and retain their catalytic property even at high temperatures like 80 degrees Celsius to 90 degrees Celsius. Okay. Now this is it, like rate defined as formation of product upon formation upon with respect to time. Now if rate can be velocity if the direction is specified, and there is thumb rule that a rate doubles or decrease by half for every 10 degrees Celsius in either direction. Okay, if rate can be doubled, so rate can be halved in every 10 degree Celsius in either direction. Okay, now this is it. Now nature of enzyme, as I told you, like now they form enzyme plus substrate, then enzyme substrate complex, then it is short lived. Okay, it is short lived, and the enzyme is unchanged right at the end. Now factors affecting enzyme activity, optimum temperature and pH is required. Now below on the optimum temperature or pH, you see like the enzyme in a temporarily inactive state, whereas at high temperature it destroys enzymatic activity because proteins are denatured by heat. Okay, so this is it. This is why they required, like they show the highest activity at a particular temperature or pH. These are optimum temperature and optimum pH. Or activity declines both below and above the optimum value, right? See in the diagram by enzymatic activity, that is pH versus enzymatic activity versus temperatures, right? Now the concentration of substrate on enzyme activity. You will see the velocity of reactions on the y-axis and substrate concentration on the x-axis. So there is a Km value which tells when the reaction is processed, the velocity of reaction gets half. So this is the Km value. It's a Michaelis constant, and Vmax you see when the now why there is a Vmax, because with the increase in the substrate concentration, the velocity of the enzymatic reaction rises at first. The reaction ultimately reaches a maximum velocity, that is Vmax, which is not exceeded by any further rise in concentration of the substrate. So this is because the enzyme molecules are fewer than the substrate molecules, and after saturation of these molecules, because enzyme molecules are very fewer, okay, than the substrate molecules, so after there are no free enzyme molecules to bind with additional substrate molecules. Okay, now the activity of enzyme is also sensitive. They can be inhibited by the inhibition process, inhibitor. Now malonate, which is one type of inhibitor,